Hello everyone, let's review for our test. We're going to do a couple of the weirder three-variable systems where you can use substitution to solve. They're actually easier that way, but it is a little bit different because we've mostly done substitution with the two variables. So you'll see how we actually quickly turn it into a two-variable system. First thing, it says Mr. Wyatt's going to Renaissance Fair. I love the Renaissance Festival. And we got adults are $12, children cost $6, seniors cost $8. And we spent $112. Okay, right. First thing, how many adults, children, seniors went? I'm going to type this because my handwriting's terrible. Let's call X the number of adults that went. So number of adults. Y will be the number of children. And Z will be the number of seniors. Z is the number of seniors. Okay? So we got just having an idea of what our variables are is going to help us, and at the end we need to make sure that everything matches up the way it should. Now, I'm going to try and use my highlighter to help you see what I'm looking at. The first equation that I'm going to write is the one that deals with money, and this is usually the one that we do really well on. All the money goes into one equation. It is $12 for each adult. It is $6 for each child, and it is $8 for this senior to go, and there's a total of $112 spent. Okay, that's usually not the one that gets you. The second equation I'm going to do is there is a group of 12 people. It does not matter if they are adults or children or seniors. There are 12 people. X plus Y plus Z equals 12. 12 people have to go. It could be 10 adults, 1 child, 1 senior. 10 plus 1 plus 1 makes 12. It could be 9 adults, 2 children, 1 senior. 9 plus 2 plus 1 is 12. Any combination that gives you 12 works. And the last equation is the trickiest. It says there are twice as many children as seniors. Now, the misconception is people just want to read English and write math. They're like, oh, twice as many children. Twice as many children as seniors. And that is backwards. Okay, and I'll show you why. I like to make a table. I'll do children, and I'll do seniors, and I'm just going to like make up some numbers. If 1 senior goes, 2 children went. If 2 seniors go, 4 children went. If 3 seniors go, 6 children went. Now let's make it a variable. If seniors are Z, if Z seniors go, you have to take this column and multiply by 2. So this is 2Z. Okay, we just did it. Children is Y. Y equals 2Z. Okay, you have to double the amount of seniors to get the children. Okay, Y and Z. Double the amount of seniors to get the children. It's kind of backwards from what you think, but you have to double the smaller amount of things to get the larger group. The larger group is double the smaller amount. Now we've got that. Once you get to there, it's actually going to be easier to solve using substitution in this case because we have Y equals. So let me show you what I'm going to do. Instead of combining equations to create A and B, I'm going to do a substitution to create A and B. So I'm going to do 12x plus 6, but I'm not going to write Y. Instead of writing Y, I'm going to write what I know Y equals, 2Z. And you see how now I only have X's and Z's, X, Z, Z. I got rid of Y. So when I simplify that, 12x plus 12z plus 8z equals 112. 12x plus 20z equals 112. I'll call that my A equation. That was line 1. I'm going to do the same thing for line 2. X plus, but I'm not going to write Y. I'm going to put 2z plus z equals 12. And then that's x plus 3z equals 12. That is my B equation. So notice how I have these two equations. I can condense them. They only have x's and z's. So I just need to solve a two-variable system now. To do that, I think what I'm going to do is probably multiply, 3 doesn't go into 20, but I can multiply 1 by negative 12 to make those opposites. So I'll leave this alone. Let go. There it is. Okay. I'll leave this guy alone, and then I'm going to multiply line B by negative 12. So this is negative 12 times line B. So negative 12x, negative 36z, and 12 times negative 12 is negative 144. Now, those cancel out. You get negative 16z equals negative 32. That's nice. When you divide both sides by negative 16, you get z equals 2. Once you have z, we can work our way back up. Actually, I can really quickly tell you y now because y is 2 times z. So y is 4, which makes sense. If there's 2 seniors, there's 4 children. To find the adults, I'll go back up to get x now. Let's see, which one can I use? X plus 3z equals 12. So x plus 3 times 2 is 12. X, that's not a 12. I was writing 6, I think. X plus 3z equals 12. X plus 6 equals 12. Yeah, x equals 6. So 6 adults, 4 children, 2 seniors. If you flip this, then this is going to be backwards, and you will say that there are twice as many seniors as children, and you did everything right except set up the problem. Okay, so just be careful. Let's do another one. This says Zach is buying party favors for his son's birthday party. There are 9 kids attending the party, and each kid's going to get a party favor. So how many of each do we need? X will be the number of bracelets. Y will be the number of necklaces. And Z will be the number of hats. Okay. Let's do the money equation first, because that's the one we're usually good at. Money, 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 and money. So we're going to say 2x plus 3y plus 1z equals 13. It's $2 per bracelet, $3 per necklace, and $1 per hat, and that makes $13. What else do we know? There are 9 kids attending the party. So if each kid gets a party favor, we need to say x plus y plus z equals 9. And the last one is there are 4 less bracelets than hats. This is going to be easy to mess up, so let's make a table. Bracelets and hats. Bracelets. I'm going to remind myself that bracelets is x and hats is z. So there are 4 less bracelets than hats. So if there's 4 hats, there's no bracelets. If there's 5 hats, there's 1 bracelet. If there's 6 hats, there's 2 bracelets. What if there's z hats? How do we get from z? What do we need to do here? We need to take z and subtract 4. However many hats there are, subtract 4, and that gets you bracelets. So x equals z minus 4. X equals z minus 4. Another way of saying that would be that there are 4 more hats than bracelets. Is that how? Yeah, 4 more hats than bracelets. So you could also say x equals, or z equals x plus 4. That would be the same thing. But once you get here, now we can just start to solve it. Okay, we've got our substitution. So I'm going to use my substitution to eliminate a variable. I'm going to do, in the top equation, 2 times z minus 4 plus 3y plus z equals 13. So instead of x, I put z minus 4. 2z minus 8 plus 3y plus z equals 13. 2z. Oh, wait, no, we can combine like terms. 2z and 1z make 3z. And probably the easiest thing to do is to add that 8 to both sides. 3z plus 3y equals, if you add 8 to both sides, 21. That's my A equation. Similarly, I'm going to plug in my substitution right here. Instead of x, I'm going to put z minus 4. So z minus 4 for x, and then plus y plus z equals 9. And then when I combine like terms there, I have z plus z, 2z plus y minus 4 equals 9. 2z plus y. If you add 4 to both sides, you get 13. That's your B equation. Now we need to decide which variable to get rid of, z or y. I'm thinking I'm going to multiply line B by negative 3. So I'll take this. I'll leave that alone. Get over here. Good. And then for my B equation, I need to multiply by negative 3. So negative 3 times line B is now negative 6z, negative 3y, and 3 times 13 is negative 39. Okay, these go away. 3 minus 6 is negative 3, and 21 minus 39 is negative 18, so z must be positive, negative 18 divided by negative 3 is positive 6. So we're in the game. We got z. Does that help us? Oh, yeah, we can get x is 2 then. Because z minus 4, 6 minus 2, or 6 minus 4 is 2. And now to get y, I'll just use this one right here. 2 times 6 plus y equals 13. 12 plus y equals 13. Y must be 1. Okay? So x, it goes bracelets, necklace, hats. Bracelets, necklaces, hats. So there are 2 bracelets, 1 necklace, and 6 hats. And remember, we said earlier, there are 4 less bracelets than hats. So if there's 6 hats, there's 4 less bracelets, and they add up to 9, so I know I'm good, okay? Those are a little trickier to set up, but once you get them set up, it's actually easier to generate your A and B equations. So make sure you guys get your study guide finished, make sure all your delta maths are done, and make sure you smash that like and subscribe.